Jai Hind everyone, my name is Anuradha Dhumale. I am from Computer Science and Engineering Department of Akgec Engineering College. Today my subject is Database Management System and my topic is Relational Data Model and Languages. First of all, we know that what is the RDBMS. RDBMS stands for Relational Database Management System. A Relational Database Management System is a database management system that is based on the relational model. There are various types of model we use in the database management system, in which relational data model is one of them. Now, this model, relational database model, is firstly introduced by Dr. E.F. Codd. RDBMS stores the data in the form of related tables. A relational database consists of collection of tables, each of which assigns a unique name. Each table is having the unique name. There are some properties of the relational tables. The first property is values are atomic. The values which are used in the table of the relational data model will be atomic. Multi-value attributes are not allowed. Okay, only the atomic values will be there in the relational data model. The second is column values are of same kind. All values in a column come from the same domain. We will teach about the constraints of the relational database model, in which I will tell you what is the domain constraint. Each row is unique. In a table, the row will be unique. Not two rows in a relational database should be identical. We use the rows and columns in the tabular format. We use rows and column in the tables, in which the rows of should be unique. No two rows in the relational table should be identical. Then sequence of columns or rows is insignificant. Columns, rows can be retrieved in any order in various sequence. Next is each column has an unique name. Each column has an unique names. The attributes name, the column names we also called as the attributes name. The attributes name or the column names of the table should be unique. Then after that, I will tell you the Codd's rule for the Dbms. There are 12 rules for the relational database model, which is implemented by or the developed by the Dr. E.F. Codd. Dr. E.F. Codd is an IBM researcher who first developed the relational data model in 1970. In 1970, Dr. E.F. Codd implemented the relational data model. First time the relational data model will be developed by Dr. E.F. Codd. After that, Dr. E.F. Codd published a list of 12 rules in which define an ideal relational database. They published the 12 rule at the time of 1970. That all rules we follow them now also. The rule 1, the information rule. This rule requires that all the data should be presented in the tabular form. Okay. The first rule, what tells the information rule? The information rule tells about the rule requires that all data should be presented in the tabular format. Like this, we make a table and all the data should be in the tabular format. The second rule is the guaranteed access rule. The second rule is the guaranteed access rule. All data should be accessible without ambiguity. This can be done through the combination of table name, primary key and column name. All the data which we used in the tabular format should be accessible, and that data will be accessible by the table name, primary key and the column name. The third is the systematic treatment of null values. Systematic treatment of the null values. RDBMS must support a representation of missing information independent of data type. The third rule tells about the missing informations of the data. That is the systematic treatment of the null values. We represents the missing value by the blank cell. Okay. The fourth rule is the dynamic online catalog based relational model. System catalog is a collection of tables that the DBMS maintain for its own use. This table holds the description of structure of the database. Which type of structures, which types of tables will be used will be told in this fourth rule. These tables are created, owned and maintained by the DBMS. The fifth rule is comprehensive data sublanguage rule. Comprehensive data sublanguage rule. In this database, the database must support at least one clearly defined language that includes the functionality for data definition, data manipulations, and data integrity. In the database management system, we use the DBMS for the data storing the information, for manipulation of the data, and data integrity. For that, we are using some languages like DDL language, DML language. Okay, the most database use SQL as their supported comprehensive language. SQL is one type of language, that is the structure query language, which is used for as a language for data manipulation, data storing, and data integrity. The rule 6 is view updating rule. Data can be presented in different logical combinations called views. Okay, data can be represented in the different logical combinations, that is view. Each view supports full range of data manipulation. The next 7th rule is high level insert, update, and delete. We do the various types of operations in database, that is the insert, update, and deletions of the data. For that, according to this rule, insert, update, and delete operations should be supported for any retrievable set rather than just for a single row in a table. Means this high level insert, update operations, delete operations should be supported for the whole data, not for a single row of the table. Okay, this operation should support all the rows and for all the columns of the table. The rule 8 is physical data independence. The next rule is physical data independence. User is isolated from the physical methods of data storing and retrieving from database. Changes can be made in physical level without affecting how user access it. The next rule is logical data independence, in which how data view should not be changed when the logical structure of the database changes. When the logical structure of the database should be changes, the first line tells that the view should not be changed. The view of the table remaining the same. This rule is difficult to satisfy. The 10th rule of the court tells about the integrity independence. In a database, in a relational data model, there are various types of attributes in which integrity should be maintained. We are using the constraints. We are using the constraints for the maintaining the integrity. Okay, for that, database must support constraints on user input. There are various types of constraints we use for the maintaining the integrity of the database, in which we use entity integrity, referential integrity. I will tell you about the entity integrity, referential integrity, domain integrity, and the key integrity in our next slides. The 11th rule of the code is a distribution independence. User should not be aware of whether a database is distributed or not. User should not be aware of whether database is distributed or not. Rule 12, non-subversion rule. If a relational system has a low-level language, that low-level language cannot be used to subvert or destroy the integrity rules expressed in higher relational language. What this rule tells about? This rule tells about the low level language cannot be used for destroying the integrity of the high level language. These are the 12 rules of the code which is published in 1970. Okay, after that we will discuss about the constraints of the relational database model, in which there are various types of constraints: integrity constraints, domain constraints, referential integrity constraints, key constraints. The first is the integrity constraints. These are the rules or constraints. These are the rules or constraints applied to the database to keep data stable, accurate, or consistent. These constraints are used for keep the data stable, accurate, and consistent. To keep database consistent, we have to follow some rules or constraints known as integrity rules. There are some integrity rules to follow. These rules for maintaining the data stable, accurate, and the consistent. The first is the entity integrity rule. In entity integrity rule, primary key is a part of it and any relations cannot be null. Okay. In entity integrity rules, we will speak about the primary key. The primary key or a part of it in any relations cannot be null. Suppose employee ID be the primary key. Okay, we will take some example. In this is the relational database model in which employee ID, employee name, salary, and department, these are the attributes. Okay, we will call these all columns called the attributes. These are the tuples. These are the tuples. These are the attributes. Okay, now employee ID is the primary key. The first entity integrity rule tell about the employee ID should not be null. The part of the employee ID should not be null. After the second row, in the second row, the employee ID cell is null. This is the null. So, blank cell in employee ID is not allowed. Blank cell, this is the blank cell. Blank cell in employee ID is not allowed. This is the first entity integrity rule. Second is the referential integrity rule. Referential integrity rule. In referential integrity, constraints are used to establish a relationship between two or more than two tables. To maintain the relationship between two or more than two tables, we are using here the referential integrity constraints. What these referential integrity constraints? The foreign key can either be null or it can have only those values which are present in the primary key with which it is related. Okay. It can be null. It can be null or only those values which are present in the primary key with it is related. Now we are taking the two table here. The first one is the employee table and the second one is the department table. Now we have this some attributes in the employee table, that is the employee ID, name, salary, and department ID. In department, I have the attributes department ID and the department name. Now here employee ID is the primary key and here department ID is the primary key. Okay, this is the primary key of the department table and this is the primary key of the employee table. Okay, now in this relation, in this two tables, in these two relations, we have to take the referential we have to apply the referential integrity rule. That means this department ID will be the referential key, foreign key in this employee table. Okay. Now, what the referential integrity rules say? Referential integrity rules say that the foreign key can either be null the foreign key can either be null or it can have only those values which are presented in the primary key with it is related. Means the value which are presented in the department ID, only those value can be take in the department ID as a foreign key. None other value than the 1A, 2C and 4C is take here as a foreign key. Like we are taking here 4F as a foreign key, which is not a foreign key, which is not allowed in the referential integrity constraint, because the 4F is not the part of the department ID of the department table. So this value is allowable, null values are allowable, but the value which are not related to different department ID is not allowed. Null value of department ID is allowed. Value 4F in department ID is not allowed because department ID is a foreign key and value 4F is not present in attributes department ID of the relation department. Okay. The next is the domain constraint. The restrictions which are applied on domains are known as the domain constraints. Restrictions, this is the very important word. The restrictions which are applied on domains known as the domain constraints. These restrictions are applied to every value of attribute. Using these constraints, we can keep consistency in the database. We are use these domain constraints for the consistency of the database. We are applying the various types of constraints. Like we can take here example of the domain constraints. Here one table is employee table is given, in which employee ID, name, age and salary, these are the attributes. Okay. Now this is the query for this relation. For making this relation, create table employee ID which is having the integer value, name that is the character value, age that is the integer value, salary that is the integer value, and primary key is employee ID. Employee ID is the primary key. Now check age is greater than 18. Here is the condition that age should be greater than 18. Now what happened in this employee table? All the values given in this table will be using the domain constraints are perfect to fit in this table. Let's see. Here employee ID is an integer. Name is the Rajiv, Gaurav, Lalit. Okay. After that, age is having greater than 18. Age should be greater than 18, but here 12 is the less than 18. So this value is not allowable. Salary is having in integer value, but we are using the character here. So these values are not allowable. Okay. Okay. Now value 12 of age attribute not allowed because age must be greater than 18. Value ABC of salary. Value ABC of salary attribute is not allowed because salary having integer data type. All the values in the salary is having the integer data type, but ABC is not the integer data type. So this value is not allowable, and this 12 which is the less than 18 should not be allowed in this domain constraints. After that, the key constraints. If any relation R, if attribute A is a primary key, then A must have a unique value. Or we can say that duplicate values in primary keys are invalid. Duplicate values are not allowed in the key constraints. All the values in the relational database should be unique. Example, in this we can see that in row 2, in tuple 2, employee ID 2, and in tuple 4, there is also the employee ID 2. So duplicate values are not allowed in these key constraints. These are the foreign key implementation. Foreign key is a key used to link two databases together. This is sometimes called a referencing key. Foreign key is a column or a combination of column whose value match a primary key in a different table. What is the foreign key? Foreign key is a column or a combination of column whose value match a primary key of the different table. The relationship between two tables matches the primary key in one of the table with the primary key. If I have two tables and those two tables having the two primary key, but two primary key in one table is not allowable, so that we are using the foreign key here. With the example, we can consider the structure of the two tables. I have two tables, customer table and the order table. In customer table and order table, if orders table already been created and foreign key has not yet been set, use the syntax for specifying foreign key by altering the table. What will be the syntax to set the foreign key for that table is, first alter table order. We have to add foreign key in the order table. So add foreign key, customer ID and references from customer ID. This syntax is used for the foreign key implementation. Thank you.